Alright, so this is the second video of the submission of the Mars game assignment. In this video, I'm going to be going over the code itself. The code is in and of itself pretty long, roughly 860 lines of assembly. However, I'm obviously not going to be explaining every single line, but I will be going over the main things that make this game work. So first off, these hex arrays that you see here correspond to each and every single fixed position and state that each and every ship could possibly be in. These are drawn on like the half of the bitmap display corresponding to each ship. So for example, if I have this as the bitmap display, instead of redrawing the whole screen all over again, causing, a bunch of lag, the health bar of like red is up on top here and stays up there, and blue's health bar is down here and stays down there. The whole background at the beginning is drawn once and is never redrawn again over the course of the game. However, this like cross section up here of the display, which corresponds to red's play area, and this one over here, which corresponds to blue's play area, are the only ones that are being redrawn accordingly throughout the game. So we can clearly see here they are very neatly named. So we have red at center, red at left, red at right, blue at center, blue at left, blue at right. These are all hex arrays which correspond to these graphics being drawn. These were obtained using a hex converter, so they were drawn manually in a photo editing software. And then the image itself was plugged into a hex converter, which converted it into an array of hex values so that MIPS can understand it and draw it accordingly with a loop that I will go over in just a moment. There are also states for the ships being damaged in each position and the ships shooting in each position, adequately named boom. Now we enter the main function, which is where the game starts. So we have just like a quick delay just to avoid, errors happening. And the main menu here is called, the drawing of the main menu is called. So if we skip to that right here, it just draws it. So it takes that hex array and the base value, the base address of where we're drawing. So T0 here contains this static data, this base address for the display right here. This is shown up here accordingly. Start index for the background. And this is used as an offset at each time, and the T0, which is the base address, is incremented by 4 because memory locations are separated into 4, as we all know, because we're working on MIPS, which is 32 bits. And at each time this is incremented by 4, this will increment this as like the base, and the offset stays the same. So it's essentially going over the hex array and drawing it pixel by pixel on the screen. So this is how all drawings are drawn in the game. Optimizations were made, as I said, in order to draw just half the screen for red and blue, changing the ship's positions, the background being only drawn once. So after that, the start menu was drawn, initialize, load background, load chip, load blue. So here in initialize, we're checking for the user's input at the beginning. So where the user inputs either S or E to start the game or exit it. Once S is received, I will show the input loop in just a moment. It will quickly go over to loading the background, loading the red and loading the blue ships, and setting certain values to certain registers that we have reserved for health. So T7 and T8 correspond to the health bars. S0 and S1 correspond to positions on the game board, if you will. The health bars are also drawn initially to be fully green, and they will change accordingly to who is hit and when, and they will decrease. And when a health bar reaches 0, that is the condition that ends up ending the game. So let's go over these real quickly. So this is loading the background, the same premise of drawing as before, loading the ships in their initial positions also. These initial positions right here were manually found. They were not just chosen to be the static data's base address from the start. This is because we want to draw the ships in a certain part of the screen. Like I said, we were cross-sectioning the display, the bitmap display. So this is necessary so that we don't have to redraw the entire screen every single time over and over again. Here it's loading the health bars. So it's just loading each and every layer of the health bar, which is a black rectangle, and inside of it is a bunch of green. And then whenever health decreases, a part of it becomes red and the other part stays green. So this is just, initially it's drawn to be black, rectangle black on the outside like an outline, and the inside is drawn to be green. And then at each time health is lost, then a red coloring is drawn over a part of the green health bar so that it would represent health decreasing. So this is all handled here. These are register values being set for these health bars as positions, and the colors green, black, and red when needed. So these are all the positions for them. T5 corresponds to a position for the health bar initially. So this was all manually done, so it may seem a bit convoluted, but all what these are really doing is just setting addresses for where each pixel is going to be drawn and what color is going to be drawn at any given point. So now that that is initially drawn, we enter the game itself. This game level function right here handles the game itself. This is probably like the most important one. So these registers over here, if we go over the code, S0 corresponds to red's position, S1 is blues, T7 is red's health, and T8 is blues' health. This stays consistent over the course of the game and over the rest of the code itself, so as to avoid conflicts later on. First, we call JRed input. Now, this may be considered some sort of an exploit. If you're playing as red, you do get the upper hand in terms of inputting first. However, I like to think of it as a chess game where white always moves first. It's just a part of the game. It's just an aspect of it. So here is where most if not all of the logic actually goes on. So right here, this part right over here is the random number generator. This is to decide whether or not it will be red shooting this time or not. We're just putting it into S5, which will be the register that we use to know whether this iteration will be a shot or not. If it does end up being an iteration where we will shoot according to the random number generator, then we will go to the method which decides to shoot. If not, we just re-update the health again, because when the players are moving, we want the health to stay consistent. And when they are moving, and if someone is shot or not, we want the health to update accordingly. So if someone is hit, we want their health to decrease, and we don't want that to conflict with other pixels on the screen, and we want it to be consistent. As someone is shot, we want the health to update immediately. So this is why this is here. And we call game level again, because the game level is essentially the loop which we keep going over and over again to keep the game running. Now, red input is indeed called red input, and I did say that red may have an upper hand, which is true, because red's input initially was favored. But if I may skip real quickly to the input loops close to the end of the code, which are right here. So we do notice that checking for red's movements happens first before blue. So I was not kidding when I did say that red did get a slight advantage. But initially it was more exacerbated in earlier designs of the game, where we had two different input loops for each, and red's was always first. Now that caused some issues with the flow of the code itself, so we went for a single loop and just a more dynamic kind of game style instead of a more traditional role-taking kind of game style where each one has their turn and then the shot is decided after a position has been determined and fixed. So now when it was decided whether or not it's time to shoot or not, we will go to who shoots. Another random number generator is going to decide who will shoot this time. 1 will be red and 2 will be blue. And accordingly, we will see if it's time for red to shoot or blue to shoot. Now I think there's a slight inconsistency here with the comments because it should be 1 for red and 0 for blue to shoot, but I digress. It's not really much of an issue, so it's just a little inconsistency with the comments. Here the code clearly states when it is 0, blue will shoot.